Hello, AP Stats. What I'm going to try to do in this video, since we've covered so many different tests and confidence intervals at this point, is try to streamline everything and help you make sense of the little nuances and differences in the plan and the do step. So I'm going to start with confidence intervals. And I'm just going to make a list of all the different types of confidence intervals that we've done. We've done a 1 proportion Z interval, a 2 proportion Z interval, a 1 sample T interval, a paired T interval, and a 2 sample T interval. So what I'm going to do is I'm going to cover these 5 and I'm going to group them together. I'm using the Z distribution or the normal distribution for a categorical variable, and I'm using the T distribution for a quantitative variable. Something that can help you remember is this, I don't know if it's a mnemonic, I don't know what it is, but ZAPTAX. If you have proportions, you're using the normal distribution. If you have means, you're using the T distribution. So if you could think of ZAPTAX, that can help you remember, when do I use Z, when do I use T? So I'm going to group these two together, 1 proportion, 2 proportion, Z interval, and I'm going to start with those. So 1 and 2 proportion, Z interval. Okay, and we're going to focus on the plan and the do step. So the plan step, as I think through my CVS, is going to be the same. Random, 10%, and large counts. Now, I like to think of this. Oh, I'll get to that in a minute when I talk about large counts. The random is just going to be, if it's a 1 proportion, it's definitely going to be a random sample. If it's 2 proportion, it could be a random sample or a random assignment if you have an experiment. 10% condition is just for 1 proportion, just stating that that sample size is less than 10% of the population. If you have 2 proportions, you're going to have to state it twice. Once for group 1, once for group 2. If it's an experiment for a 2 proportions interval, you will not check the 10% condition because you're not sampling. You're most likely having volunteers. Large counts condition. The way that I remember this, the word categorical has 1 T in it. So the magic number for large counts is 10. And this is, do I have at least 10 successes and 10 failures? As we've talked about in class, don't use any symbols. For 1 proportion, it's really this. Are these both at least 10? And then for 2 proportion, you're going to do the same thing, but you're going to have to use sample size 1 and proportion 1, and then again, sample size 2 and proportion 2. So for 2 proportion, you're going to have 4 numbers that you're seeing if they're all at least 10. If they are, the sampling distribution is approximately normal, and we're good to go. There are absolutely no degrees of freedom when you're using the normal distribution, so you don't need to worry about that. So the plan step is going to be exactly the same. You may just need to check it twice for both groups. When we get to the do step for these 1 and 2 proportion Z intervals, I'm going to reference the formula sheet because I think this is extremely important. All confidence intervals follow the same format: a statistic plus or minus a critical value times the standard error. And this product of the critical value and the standard error is called the margin of error. So these 3 components, 2 of the 3 are on your formula sheet. So if I flip over on the back here, I have the sampling distributions for proportions, and I have for 1 population and 2. So this is a 1 proportion, this is a 2 proportion. And I'm just going to look specifically. This first column represents the statistic. So it's just the sample proportion. For 2 proportion, it's the difference in the sample proportions. Now, when you get to the standard error, that's the formula for 1 proportion. For 2 proportion, that's it. Okay, I'm going to come back to this when I talk about tests in the next video. So for confidence interval, that's your standard error. So when I'm setting this up in the do step, for a 1 proportion, it's the sample proportion plus or minus the critical value, which comes from doing inverse norm of the area in one tail. So for example, if I have a 90% confidence interval, it would be inverse norm of 0.05. You're going to write whatever that number is here. So I guess you're not going to be writing inverse norm here. You're going to write the number times the standard error, which is just this formula from your formula sheet, sample proportion times its complement divided by n. And that's it. For two proportion, the statistic is the difference in the proportions. So it's going to be the sample proportion for group 1 minus the sample proportion for group 2, plus or minus. The inverse norm is going to be exactly the same. You're just going to have a critical z value from that, whatever that is. And then the standard error is just right from the formula sheet. The sample proportion for the first group times its complement divided by that sample size, and then plus the same thing for the second group. So the first sample proportion minus its complement, or times its complement divided by the sample size, plus the second times its complement divided by its sample size. We're just adding variances. So in essence, if I square this, I'm getting that. So I'm adding the variances and then taking the square root, which is a concept that we've learned earlier. So that's for confidence intervals for proportions. So now let's move on to confidence intervals for means. Okay, so we have three different ones. We have the one sample, two sample, and paired. So I'm going to kind of group the one sample and paired together because they're very similar, and then I'll move on to the two sample. So actually, for the plan step, I'll do all three together. So for the plan step, you're still going to have your CVS. For the random condition, it's going to be the same as it was for proportions. If it's a one sample, it's going to be a random sample of something. If it's paired or two sample, then you're talking about it could be an experiment or it could be two random samples. So you're going to be talking about either random assignment or random samples, independent random samples. For the variability, if it's an experiment, you do not need to check the 10% condition. If it's not, similar to what we did for proportions, if it's a one sample t interval, you're going to need to check this once. If it's a two sample t interval, you're going to need to check this twice, assuming it's not an experiment. And then now for the shape, it's the normal / large sample condition. It doesn't matter if you know the name of the condition, it's what you're saying when you check it. So I'm assessing normality here. I'm using the central limit theorem or box plots. So they could theoretically tell you the populations are normally distributed. Very unlikely, but it could happen. So I'm really going to focus in on the other two. Is the sample size at least 30? If it is, the central limit theorem applies. Now, if you have two sample sizes to check, as in a two sample t interval, you're going to need to check that both sample sizes are at least 30. So the central limit theorem is going to apply for both, meaning the sampling distribution of the difference will be approximately normal. The other option is your sample sizes are not at least 30 and they haven't told you anything about the population shape, in which case you're going to have to create a box plot. Now, there's three different scenarios for the box plot. For box plot for a one sample, you're just going to plug the data into list 1 and do a box plot of list 1. For paired, you're going to have data in list 1, you're going to have data in list 2, and you're going to have to create a list of the differences, and you're going to make a box plot of that list of differences, which will most likely be in list 3. For two sample, you're going to have data in list 1 and list 2, but these are not paired. So you're going to make a box plot of list 1 and a box plot of list 2. So you're going to have two separate box plots here. So degrees of freedom is going to be very, very similar for these. So degrees of freedom for one sample is your sample size minus 1. For paired, it's the number of pairs minus 1. for 2 sample, it's your smaller sample size minus 1. So for example, if you have a sample size of 40 and 30, the degrees of freedom would be 30. The smaller of the 2 sample sizes minus 1, 29. So that's the plan step. How are we doing on time? Okay, let me get to the do step. So the do step for these different intervals, I'm going to reference the formula sheet again. Every confidence interval we create has the same format. Statistic plus or minus critical value times the standard error. So now I'm going to, on the back, look at the means for one population. The statistic is just the sample mean. For 2 populations, it's the difference between the sample means. And then I have my standard error formula. Okay, so for 1 sample, the way this is going to look for a 1 sample t interval, it's going to be the sample mean plus or minus a critical t value, and that's going to come from doing inverse t, the area in one tail, comma, the degrees of freedom. So if you have a 95% confidence interval, there'd be 2.5% in each tail. So it'd be inverse t of 0.025, and then whatever the degrees of freedom are, that's going to give you this critical t value. Standard error for that 1 sample is listed here. Sample standard deviation divided by the square root of the sample size. So times s divided by the square root of n. Okay. If you need to calculate the sample mean and the sample standard deviation, because they gave you the raw data and you created a box plot, this is going to happen by doing one variable stats on list 1 in your calculator. So let's switch to paired. This is going to be exactly the same, except the way that you get the data is going to be different. We talked about in paired, you're going to have some data in list 1, some in list 2. It might be like a before and after. And then you have this new list of the differences. Everything that we're going to do is going to be in relation to the list of the differences. So this is really technically going to be the sample mean difference plus or minus your critical t value, which is calculated the same exact way, times the standard deviation of the differences divided by the square root of the sample size. So in order to get the standard deviation of the difference and the mean of the difference, this is going to be one variable stats on your calculator, but you're doing it on list 3, the list of the differences. The last confidence interval, 2 sample. So going back to the formula sheet, the statistic is the difference between the sample means. So I'm going to start with that. Sample mean from group 1 minus the sample mean from group 2, plus or minus my critical t value. It's calculated the same exact way. The area in one tail, comma, the degrees of freedom. As we spoke about a minute ago, the degrees of freedom are the smaller of the 2 sample sizes minus 1, times the standard error, which is here for under means, 2 populations. I'm adding variances dividing by the square root of the sample size. So this would be times the square root of the sample standard deviation for group 1 squared divided by that sample size, and the same idea for group 2. So where do you get this information from? All right, let me get the highlighter out actually. Those 2 values, the highlighted values, are going to come from you doing one variable stat on list 1. And then these other values are going to come from doing one variable stat on list 2. So hopefully this video was helpful and you could see all the similarities and consistencies and how to really utilize your formula sheet that you're going to get on your AP exam to make sense of these different types of confidence intervals.